Today I'll be covering equivalent fractions. Consider the fraction 2/4. So first I'm going to divide a rectangle up into 4 pieces and shade 2 of them. Now if we compare that with the rectangle I drew below it, and I only split it up into 2 parts instead of 4, don't these two represent the same as one of these? They look like the same area. And what fraction would represent this rectangle? 1/2. And that's the concept of equivalent fractions. In other words, 2/4 is equal to 1/2. Like I said, these are called equivalent fractions. They represent the same part of the whole. So the same part of the whole rectangle. And they represent the same spot on the number line. Equivalent fractions come in handy when you add and subtract fractions. Example 1. Use a number line to determine if 1/3 and 2/6 are equivalent fractions. Since 1/3 and 2/6 are both improper fractions, I only divided the area up between 0 and 1. So the first I'm going to do is graph 1/3. So I had to split the area up into 3 parts. So 1, 2, 1, 2, 3 parts, yep. Next, I count 1 over. And that's where 1/3 is. Now for 2/6, I had to split it up into 6 equal parts. 1, 2, 3, 4, 5, 6. Now I have to count 2 over. 1, 2. And if I look, they are on the exact same spot on the number line. So yes, they are equivalent fractions. So 1/3 equals 2/6. Now here are some equivalent fractions. 1/2 equals 2/4. 4/10 equals 2/5. 5/6 equals 15/18. And 25/40 equals 5/8. Do you notice a pattern? Well, I noticed that they're basically multiples of each other. Like if I multiply this by 2, I get 2, and if I multiply this by 2, I get 4. If I divide this by 2, I get 2, and if I divide 10 by 2, I get 5. If I multiply 5 by 3, I get 15. If I multiply 6 by 3, I get 18. If I divide 25 by 5, I get 5. If I divide 40 by 5, I get 8. So that's a pattern with equivalent fractions. And that brings us up into the fundamental principle of fractions, which states if you multiply or divide the numerator as well as the denominator, you will get an equivalent fraction. In other words, what you do to the top, you have to do to the bottom. So if I have a over b, and I multiply a by c and b by c, I will get an equivalent fraction of ac over bc. Same if I take a divided by c and b divided by c, you'll get an equivalent fraction of a divided by c over b divided by c. And this will help us find equivalent fractions, and this is the main part that I mentioned earlier for addition and subtraction of fractions. Now example 2, I want to write 3/5 with a denominator of 25. So what I do is I write out my original fraction equals a new fraction with a denominator of 25. Now, since I have both denominators, let's compare them. What is the relationship between 5 and 25? Well, 25 is 5 times 5. And remember the rule, wherever you do the bottom, you have to do the top, or wherever you do the top, you have to do the bottom. So since I've multiplied the denominator by 5, I have to multiply the numerator by 5. So 3 times 5 is 15. So 3/5 with a denominator of 25 is 15 25ths. Now 6 with a denominator of 2. Well, I know 6 is going to equal a fraction with a denominator of 2. But I don't have a denominator here. I only have 6. So how can I compare denominators like I did on the last one? Well, with whole numbers, the denominator is always assumed to be 1, because in a fraction this basically says 6 divided by 1, which is 6. So now I do have denominators I can compare. What's the relationship between 1 and 2? 2 is 2 times 1. So I have to multiply the 6 by 2. 6 times 2 is 12. So 6 with a denominator of 2 is 12 halves. Now to throw some variables in there. 5 over 3b with a denominator of 21b. Denominator of 21b. I notice that both denominators have a b, so I know I don't have to multiply anything there. So basically all you're comparing is the 3 to the 21. What's the relationship there? Well, 3 times 7 is 21, which means I have to multiply the 5 by 7. And 5 times 7 is 35. So 5 over 3b with a denominator of 21b is equal to 35 over 21b. And that's equivalent fractions, and as I keep saying, you have to get this down for addition and subtraction of fractions. Have a nice day.